Hello 152 students. I've created an example 8 from section 6.2b lesson notes, and you will notice that this is the same region that we had in example 7, except this problem is now revolved around the axis y equals -1. So what I'm going to do, y equals -2, excuse me. So what I'm going to do is I'm going to draw the region again. So my region, if you recall, went through e to the x plus 2. That would go through at 3, right? Go up. Whoa, I apparently am nervous. And we also had y equals 0, x equals 0, and x equals 1. So I'm going to go ahead and make that one in green. So again, we are looking at this region right in here. Sorry, I'm kind of looking at my previous notes, and what we are doing though is we are revolving, and this value is 1. And we are on the x-axis here. This is the x-axis. This is the y-axis. That's a value of 3. I'm not sure what this value is, but I'm not sure that we need it. We're trying to revolve around the axis -2. So I'm going to draw that axis right here. That's the axis y equals -2. So all of this region right here is going to move down to this region. So what I typically do is kind of do some counting. So if I notice here, this is a distance of 3, and this here is a distance of 2. So I'm going to go another distance of 2, and then another distance of 3, and that's where this point is going to end up. So that's 2, 4, 5, 6, 7. So this is going to be at -7. I'm going to be arching this way, if you notice. And then this line, which is red here, this line is at 0, but it's revolving around -2, so it's going to be down here at 2. It's revolving around this line. Oh, it did not change to red now, did it? Then this green line will still be here. Okay, so this has been reflected across this line by just kind of counting. Let me go ahead and draw this circle here, and remember there's going to be an open circle here. Now I'm going to need to draw another cross-section. I'm going to draw that cross-section in blue this time. Trying to make it nice and big so we can see it. Okay, so hopefully we can see this washer. I'll just draw this washer right here, kind of. Now, and it has a little bit of thickness, and I could draw a little bit of thickness here, but I'm going to be a little lazy. So our setup is always going to be the same. It is going to be our volume. It's going to be, now since I'm slicing it this way, once again it is a dx. Anytime I revolve around a horizontal axis like y equals -2, revolve, the circle is going to be at a slice of delta x. So once again I'm going to have the volume is going to be the integral from a to b. Now in this case, remember, this is 1 and this is 0, so I'm going to still be going from 0 to 1 like I was in the previous example. And it's going to be pi, and this is going to be the area of the outer circle, remember. So this is going to be pi radius, the radius of the outer circle, squared, minus pi times the radius of the inner circle squared. And that's going to be a dx. So the key here, the difficulty, and I agree that it is difficult, is to figure out what the inner and the outer radius is. So now if you notice, there's one of the radii that doesn't change, and that is the inner one. You'll notice the circle on the outside, the inner circle remains the same, just as out here. And that radius happens to be this value. So that inner radius, which I will go ahead and mark in green, this inner radius that goes from here to here, or from here to here, is a value of 2. Sometimes people like to think of it, as a subtraction, and I'm basically taking this 0 value, y equals 0, and I'm taking 0 minus a negative 2, and that gives me the radius of 2, if you like that. So this radius here is going to be 2. Now I'll fill in everything else in just a second. So I am kind of still doing a subtraction, if you want to think of it that way. My other radius is going from this center point all the way up here. I need that to be in black. So it's going to go from here all the way down here. Now if you remember, this right here, so this distance right here, that's my y distance, which is dependent upon this e to the x plus 2. That distance right there. We've already shown that this distance right here is 2. So instead of subtracting, because we're adding a distance here, it's like we're taking e to the x plus 2 and adding another 2. But that sometimes tends to be confusing for people, so we just take our top function, which is, the radius of the outer. We can take our top function, which is this e to the x. I did it again. So help me goodness. Whew, this is pretty frustrating. I hit something with the palm of my hand. Whew, it's frustrating. Okay, so we're really going to take this e to the x plus 2, and we're going to subtract this lower function. So what we're doing here is we're taking minus, and then the lower function happens to be negative 2. So you'll see that we actually do end up adding the 2. So whether you think of it as this distance plus a distance, or this subtracted from a value, this minus a negative value, either way you'll end up with ex plus 4. And that's going to be my inner radius, or my outer radius, excuse me. So my entire volume will have a pi here, goes from 0 to 1. I'm going to square that. Again, that's my outside radius right here, minus the inside radius, which again is just 2 in this case. Sometimes it will also be dependent on a function. And typically what I would do is factor out that pi. I would choose not to do this by hand. Rather, I would plug this into my calculator. I have not done that ahead of time, so I'm going to go ahead and do that right now. I'm going to hit math and go to fint, and I'm going to hit parentheses e to the x plus 4 squared minus 4, comma, x, comma 0, comma 1. So that's going to give me 28.94, and I'm going to multiply that by pi. And that's going to give me an answer of 90.92 units cubed. And that's how we deal with something that's about a negative axis, which basically we subtract the two functions to get that outer radius, but by subtracting a negative 2 we end up adding that value. Hope this helps, and let's move on. I'm going to do an example 9 as well.